So what we're going to do today is we're going to actually find out about some characteristics of a quadratic. Just remember that a quadratic function is always in standard form when it looks like y equals ax squared plus bx plus c. Okay, so a is whatever's attached to x squared, b is whatever attached to x, and c is just the constant. Whenever you graph one of these quadratics, what you get is a smooth, symmetric U-shaped graph. It's called a parabola. What's going to happen with the parabola is you've got a turning point, and this is what's called the vertex. So the vertex is the turning point of the parabola, and the fact that it's a point, it's an ordered pair, and it's going to be an xy coordinate somewhere on your grid. The fact that it's symmetric means that if you were to fold this parabola in half through the vertex, you create something called the axis of symmetry. And the axis of symmetry is the x value of the vertex. And it's written as an equation, which is going to be x equals, and who knows what that value is going to be. The value could be 2, 3, -5, who knows. One of the ways to remember the axis of symmetry is if you look at the last three letters, it says x is. So the axis of symmetry is what the x is. And you'll write it in equation format. So if the vertex is 2, -3, the axis of symmetry is what the x is. And the x in this first vertex is 2. When you look at the next vertex, 0, 1, the axis of symmetry is the equation that's x is 0, x equal to 0. And then on the second or the last vertex, what is the x? And the x is -4, so the axis of symmetry is going to be the line that is x equals -4. If you go back up to the actual quadratic function, if you look at this y equals ax squared plus bx plus c, if the a term, if the thing attached to the x squared is positive, then the parabola is going to open up and the vertex is going to be a minimum. If the a term is negative, then the parabola is going to open down and the vertex is going to be a maximum. Just going to show you what these things would actually look like. I'm going to make up an equation here. Put the calculator up. So if I were to take a look at some quadratic functions, turn this thing on, it's probably already plugged in here anyway. So if I were to make up a quadratic function, and I'm just going to get rid of these guys too. If I just were to type in y equals x squared, I don't have a b and a c. It doesn't really matter. It's plus 0x plus 0, I guess. Then my parabola opens upwards, okay? If I then were to go and change this and make it a negative of x squared, and I graph this one, now you see that the parabola opens downward, okay? And then the axis of symmetry is that line that goes right through the middle of the vertex. Alrighty. So zeros of a function. Zeros of a function happen to be the x values or nx value that makes the function equal to 0. It also sometimes is known as the root or the solution. And a quadratic function may have either none, I got to move this again, 1, or 2 zeros. So if you take a look at this first graph right here, this parabola never crosses over the x-axis. This parabola touches the x-axis at one point. This parabola, let me move this back up. That wasn't good. This parabola touches the x-axis at 2 points. So this then does not have any zeros. So there are no zeros of the function here. There's 1 0 in a graph like this, and then there are 2 zeros in a graph like that. We talked about in class today how if you take a regular equation, you factor it, and then you solve for it, then those solutions happen to be those roots, or that parabola is going to cross your x-axis. Okay. We are going to go out of order just a tad. I'm going to skip these 2 graphs for right now. I'm going to go down to this thing. So this one says, in order to find the axis of symmetry and to begin finding the x value of the vertex, you need to have this formula memorized. And the formula is going to be that the x value is x equals the opposite of the b value divided by 2 times a, by twice a. So it's x equals negative b over 2a. Not so difficult. So what you're going to do here is this first quadratic function, the standard form would be ax squared plus bx plus c. Well, you need to identify what is the a value and what's the b value. Well, the a value is the imaginary number that's attached to x squared, and the b value is the number that's actually attached to x. So this then would tell you a should be 1 because it's a 1x squared, and b should be 3. When you plug it into the formula says x equals the opposite or the negative b over twice a. Well, we know that b is 3, a is 1, and when you simplify and do your math, then the axis of symmetry is the equation of x equals negative 3 halves. That's all you have to do. X equals negative 3 halves. With that, let's jump to, not there. Let's keep going on this sheet. This one says find the axis of symmetry and the vertex. I can move this over. Here we go. So on the first one, to find the axis of symmetry, we have to use the formula x equals negative b over 2a. So this is going to be axis of symmetry. I'm just going to abbreviate that there. If I look at my a and my b, I should realize that a attached to x squared is 5. B attached to x is negative 10. So I'm going to kind of write this off on the side. I know that my a value is 5. My b value is negative 10. My formula says x equals negative b over 2a. Well, b is a negative 10. A is a 5. When I do the math, I get double negatives, becomes a positive, and then 10 divided by 10 is 1. So the equation for the axis of symmetry is x equals 1. That's the first part. That's basically like axis of symmetry. So I'm looking for, this is like A. This is the first thing I do. The second thing I do is try to find the vertex. So the vertex says, well, in order to do that, the vertex, then I know that my equation is y equals 5x squared minus 10x plus 3. Well, x I found from the axis of symmetry to be 1, so I'm going to plug in a 1 wherever I saw the x. Now when I do the math, 1 squared is 1, 5 times 1 is 5, 10 times 1 is 10, plus 3. So y equals 5 minus 10, which is negative 5, and negative 5 plus 3 is negative 2. Y equals 2. What that's now allowed me to find is my vertex, it's an ordered pair, is 1 comma negative 2. And now I've answered B. So we've done two things. We've done axis of symmetry, x equals 1, vertex, 1 comma negative 2. Let's try this next one. On this next one, I know that my a value is a -1 because it's -1x squared. My b value is a -2 because that's what's attached to the x. The formula says x is -b over twice a. Well, b is -2, a is -1. When you do the math here, you get x equals +2 over -2, which is -1. So I'm going to abbreviate this as AOS, axis of symmetry. The equation x equals -1, excuse me. To find the vertex, I'm going to go back to the original equation, and I know that y equals -x squared minus 2x. Remember, we found that the axis of symmetry was x is -1. -1 gets plugged in. Be careful on your math here. You've got to square -1 first, which is +1, and then apply the negative. -2 times -1 is +2, so y equals 1, which means my vertex is when x is -1, y is +1. Make sure you're good with that. Okay, let's try another one. I think there's 2 more left. This one. So my a equals 1, my b equals -6. My axis of symmetry is -b over twice a. b again, -6, a is 1. When we do the math, you're going to get -6 over 2. So the axis of symmetry is the equation x equals 3. Right? Double negatives over here. So here's the first part of it. Now with the axis of symmetry, you've got to plug in the 3 wherever you see an x to find your vertex. Y equals x squared minus 6x plus 9. Remember, x was 3. So y equals 9 minus 18 plus 9. Y equals, well, 9 minus 18 is -9. -9 plus 9 is 0. So now we have our vertex, which is going to be 3, 0. Last one. So A equals 2, B equals -6, axis of symmetry, x equals -b over twice a. B is -6, a is 2. When I do the math here, you're now going to get a fraction that's simplified. You get 6 over 4. Well, 6 over 4 can be simplified, divided by 2, which becomes 3/2. So this is our axis of symmetry. Now when I go in for the vertex, the math is going to be a little bit more challenging. So now I'm going to go for y equals 2x squared minus 6x. It's going to be 3/2 that gets plugged in. So I'll take this a little bit more slowly. This becomes 2 times 9 over 4 minus 18 over 2. Right, just multiply my fractions, which means this is going to become 1, 2, 9/2 minus 9. And then if I change my 9 into halves, or I could even do this, maybe even make it a decimal, might make it easier. Let's see, why don't we make 9/2 4.5 minus 9, which y would then become -4.5. Make sure you go with that. 9 divided by 2 is 4.5. 9 minus 4.5 is 4.5, but it's going to be negative. So the vertex here, not as nice as the other ones, becomes 3/2 -4.5. It's okay that you've got a mixture of decimals and fractions. Feel free to make 3/2 1.5. Doesn't matter. Okay? I am not going to go back and discuss those other two pieces because the homework you're not even graphing. So for the homework, what you're going to have to do is you're going to have to factor some of those quadratics first to find your zeros, and then you're going to find the axis symmetry in the vertex. Good luck.